The following is the details and objectives of this course. Please read it carefully, and start the course. Depending on the method fuel is injected into the combustion chamber, gasoline engine is categorized into MPI and GDI. In an MPI engine, fuel is injected at intake port. Then the fuel is mixed with air in the intake port, passes through the intake valve and into the combustion chamber. But unlike MPI engine, high-pressure fuel is directly injected into the combustion chamber in GDI engine. This direct injection into the combustion chamber increased both performance and fuel efficiency, while reducing emission gas. In this session, we will examine the GDI type gasoline fuel system. When we look at the changing trend in gasoline engine, demand is increasing for high performance, with small engine while creating less emission gas. As a result, all automobile manufacturers are either changing from existing MPI type engines to GDI type engines, or newly developing GDI technology to satisfy this increasing demand. In line with this global trend, main body of the GDI engine is composed of ball piston form based on the shape of piston head, roller timing chain, and special coating to minimize friction on major components. Now, let's go over the characteristics of each component in detail. First, we will learn about the characteristics of piston formation. Since fuel is directly injected into the combustion chamber in GDI engine, piston shape is very important. Unlike MPI engine, the piston head section in GDI engine is in a sunken shape of a bowl. The reason for this is to direct the fuel injected into the combustion chamber upwards. As a result, the fuel injected into the combustion chamber collides around the spark plug, which creates stratification effect and increases combustion stability. In other words, the fuel is gathered around the spark plug for improved combustion. In addition, the compression ratio is increased due to change in piston shape, which also roller timing chain is used in GDI engine. First, we will learn about the characteristics of piston formation. Since fuel is directly injected into the combustion chamber in GDI engine, piston shape is very important. Unlike MPI engine, the piston head section in GDI engine is in a sunken shape of a bowl. The reason for this is to direct the fuel injected into the combustion chamber upwards. As a result, the fuel injected into the combustion chamber collides around the spark plug, which creates stratification effect and increases combustion stability. In other words, the fuel is gathered around the spark plug for improved combustion. In addition, the compresses combustion stability and increases combustion stability. Stability. In other words, the fuel is gathered around the spark plug for improved combustion. In addition, the compression ratio is increased due to change in piston shape, which also improved fuel efficiency at partial load range. Click on the tip button to view the difference in the piston shape between the MPI and GDI engine. Roller timing chain is used in GDI engine. This is because GDI engine generates soot, which is oxide created by combustion. First, we will learn about the characteristics of piston formation. Fuel is gathered. As a result, the fuel injected into the combustion chamber collates around the spark plug, which creates stratification effect and increases combustion stability and GDI engine. Roller timing chain is used in GDI engine. This is because GDI engine generates soot, which is oxide created by combustion. When soot is mixed with engine oil, it may increase friction on major components. Roller chain falls behind in terms of operation noise compared to silent chain, but has lower friction. This provides roller chain with high abrasive resistance. Click tip button to view the pros and cons of the roller chain and silent chain in more detail. You can improve fuel efficiency when you minimize engine friction. You can also achieve improved durability while reducing noise and vibration. Friction was reduced through application of valve tappet, piston ring, and special coating on the piston, and achieved improved fuel efficiency. Fuel system for GDI engine is mainly divided into high pressure line and low pressure line. Low pressure line uses the low pressure pump installed in the fuel tank to send the fuel to the high pressure pump. High pressure line uses the high pressure pump driven by the cam to inject the fuel at pressure of up to 150 bar. We will now examine more closely on the components of the high-pressure fuel line. High-pressure fuel line is integrated with the high-pressure fuel pump, which generates high pressure in the fuel, and the pressure regulator valve, for controlling the fuel pressure. It also includes the fuel rail, which stores and distributes high-pressure fuel to each injector, rail pressure sensor, which detects rail pressure and engages precision control through feedback, and high-pressure injectors, which directly injects fuel into the combustion chamber. Click on each component to view more detailed information. GDI engine injects fuel at higher pressure than MPI engine. Fuel pressure in MPI engine is controlled at approximately 3.5 bar. But in GDI engine, fuel is injected with pressure between 30 to 150 bar, based on the engine load. Fuel pressure per RPM in GDI engine is as follows. Click the tip button and review the service data in detail. GDI system not only controls injection pressure, but also engages control for optimum injection timing. Since fuel is directly into the combustion chamber in GDI engine, injection timing is not restricted by the open. Next, we will go over the effects of GDI system for various driving conditions. Click each condition to see more details. When starting the engine, the temperature inside the combustion chamber is cold, so injected fuel is not ignited easily. In such a case, the fuel is injected at compression stroke to create stratification effect between air and fuel. This concentrates fuel around the spark plug. This improves ignitability for better engine start and reduces fuel consumption. If catalyst temperature is low and results in poor emission gas purification performance, then the temperature must be quickly increased. Accordingly, the fuel is injected at both intake and compression strokes. Fuel injected during intake strokes has sufficient time to vaporize, and partial injection is made at the end of the compression stroke to concentrate fuel around the spark plug. This increases combustion stability, and the ignition timing is delayed to increase the exhaust gas temperature. In other words, Increased exhaust gas temperature shortens catalytic conversion time, which reduces the emission gas. Fuel is injected at intake stroke during normal driving. This not only increases combustion efficiency, but when the fuel directly injected in the combustion chamber vaporizes, it reduces the temperature in the combustion chamber and increases the intake air volume. At this point, the compression ratio increases, which results in improved engine performance. Now, let's wrap up what we've learned today.